let's now talk about a bit of the introduction and background of the rubber um, balloon method. Now, first, it is an on-site test to determine the volume of an excavated soil so that we will be able to calculate the soil density of the soil hole. Now, the experiment consists of a calibrated vessel, balances, drying apparatus, and miscellaneous equipment such as picks or digging materials in general, as well as containers for the soil. It's primarily used for excavation holes, and is generally suitable for well compacted soils rather than the soft ones, due to it not being very effective to soils that deform easily. A bit of the history about this method was first introduced in the 1950s for finding soil density, because at that time there aren't many apparatus available for that to happen. Even more scarce if we say a specific area in which they're looking for the overall volume of a certain hole of soil. So after 6 years, this became approved because of its precision at that time. But although recent recent improvements made it so that the actual volume versus the one that we acquire using this method is lower. That's why further calculations was required for engineers, specifically geotechnical engineers at that time. So how it came to be is that Iowa was seeking an apparatus to measure in-place density. Hence, they developed this method. And since it was further improved after using in Alaska, USA. And like I said, this further became an actual apparatus because it was manufactured by a prestige a German company at that time.
The significance of the rubber balloon method is it measures the in-place density and unit weight of compacted or firmly packed soil. It also determines the inorganic, soil deposit, soil aggregate mixtures, and other equivalent hard materials densities and unit weights. The test specimen for the rubber balloon method is taken from a compacted fill or embankment made of fine or granular grained soils with negligible levels of rock or coarse materials. Undisturbed or in situ soils can also be used as a sample provided that it will not deform under pressure imposed during the test. Soils that are very plastic, organic, or saturated are unsuitable for this test as it will deform due to the pressure.
The apparatus needed in conducting the rubber balloon method are the balloon density meter, a rubber bulb pump, a density plate with fasteners, some rubber balloons, a soil auger or trowel, a moisture-tight container, a weight balance, and a drying oven. For its procedure, the first step is to prepare a flat and smooth surface of the soil in the field where the density needs to be found. Secondly, the density plate must be placed on the prepared surface and must be fixed using the provided fasteners. It should be remembered that the plate should not move while conducting the test. Next would be to position the balloon density meter exactly on the hole provided in the density plate. After that, the rubber bulb pump must be placed in the control valve and water must be pumped into the balloon which is placed at the bottom of the density meter. Remember that the water must be pumped until the water level in the density meter reaches its lowest position. Note down the reading as the initial volume. After recording the initial volume, the rubber bulb pump must be inverted and the water must be pumped back into its original position. Now, the density meter must be removed and use the soil auger or trowel to dig a hole. It is important to take note that the hole dug should have a minimum of 4 inches in diameter and 5 inches deep. Then, the soil excavated from the hole must be completely collected and stored in a moisture-tight container. Its weight should be noted and is also used to determine the water content of the soil. Next would be to place the balloon density meter over the excavated hole and pump the water into the balloon using a rubber bulb pump. At this time, once the water level reaches its lowest position, note the reading as the final volume. Lastly, pump the water back into its original level using a rubber bulb pump with the vacuum side connected to the control valve.
For the calculation of the needed data for analysis, first we have to identify legends and formulas. The values we can get from the procedure is the weight of soil excavated, volume of the initial reading, and the volume of the second reading. We can get the volume of the whole by diminishing the volume of the first reading from the second reading. Since both of the weight and volume of the soil is known, we can compute for the wet density of soil. Moreover, to get the moisture content, the weight of the wet and dry state are taken. The dry density can be calculated once the volume of water content is available. In this example, the reading on the initial procedure is 2,883.84 cubic centimeter, while the second reading is 7,809.4387 cubic centimeter. The weight of the excavated soil is 11,005 grams, while after drying, the calculated moisture content is 11%. After using the formulas given, the dry density of soil sits at 2.01 grams per cubic centimeter. The obtained data is useful for engineering projects where construction stands. This enables the engineers to determine if the soil is ideal or compact enough to hold against a certain load. If not, adjustments will be made according to the gathered data to achieve the desired requirement. The precision of the procedure is important to ensure the consistent data obtained for evaluation of a construction project. The formula for precision in percent is equal to the actual value minus the experimental value, all over the actual value. This formula can be used to determine inconsistencies with the data. One inconsistency to be measured is the calibration of the apparatus. In this example, an experiment was conducted by Mohammed in 2021 where there is an actual value of volume taken using the plexiglass container and the experimental value taken by the rubber balloon soil densitometer. The precision in percentage is low and stays below 1 from second event to 8th event. However, the first event has a precision percent at 2.08, which is relatively high. For the reliability of the rubber balloon method, it is highly precise when taking the volume of an excavated hole, as the rubber and water takes the shape of the hole gap, diminishing the gaps that might cause an inconsistency. Moreover, we can conclude that the volume taken from the reading of the apparatus is equal to the volume of the balloon.
For the summary, one of the earliest types of soil testing is the rubber balloon method. It was initially used in 1950 to determine the soil density. This technique was accepted and further enhanced by a German business due to its accuracy as an instrument that assessed in-place density. By estimating the value of an excavated soil, this test determines the density of soil on site. Additionally, it is used to excavation holes. Using this technique's procedure, the in-place density and unit weight of compacted or tightly packed soil are also measured. This method can also be used to calculate the densities and unit weights of inorganic natural soil deposits, soil aggregates combination, and other comparable hard materials. Thus, there are several formulas are used for this method. An example of this is that B equals to B2 minus B1. Second is the Y equals to W over B. However, this method of soils unsuitable for soils that are organic, saturated, and have high plasticity.
When conducting this experiment, various factors need to be taken into account. There are ways to prevent these errors, however, the data provided are not completely accurate. Make sure to check the equipment and materials used to measure the soil to ensure more accurate results. If the instruments are not calibrated or have mechanical issues, the results will be different. In order to avoid small margins of error when gathering the data, the student should also ensure that the equipment is calibrated.